So first and the foremost, I would like to thank the members of the committee and also two former members, Ryan and Michael, and also the entire team of the two projects, and also the admin HR team who helped me to come to this point. And today I'm here trying to articulate the things that I did in the last 3 years. So the topic is advancing GIS analysis for parks and also an econometric model for visitors' choice in forest recreation. So it's quite simple, the background, how we were scoping the research, Brian and I, and then the study one, the noise or the soundscape, and study two, trying to compare the aircraft tracking systems. And the third one is the economic model, visitors' choice model, and a few about how this can be taken forward in future. So as we know, parks and the forests, they incorporate different biomes, latitude, longitude, ecozones, climatic regimes, and diverse flora and fauna. And NPS has got 431 units covering more than 85 million acres. So similarly, the forest system has 154 national forests and the grasslands, Simran grasslands like that, with an area of 193 million acres. And they provide the recreation activities and helping people to connect with nature, culture, and at the same time providing opportunities for advancing science, research, and arts. And the economic side, we have seen that 325.5 million people visited 394 NPS units in 2023. An estimated 159 million people visited the national forests from 2018 to 2021. And the annual spending in the forests, it's $11 billion in 2021 by those users. So we can see how much they can contribute to the GDP and the local economy. And then comes the monitoring, inventory, survey, assessment, whatever we call it, in every organization and also in the parks and the forests, which is more about collecting the information about the natural resources, status, or strategies, measurement. And we have the ecosystem indicators. And in my previous office, I was leading the monitoring unit then. And basically, it was a monitoring of the condition of the natural resources. And at the same time, the visitors' use experience. And we have the noise monitoring, the light pollution monitoring, land use, land cover, species, habitat monitoring, the climate change VA, and then the visitors' uses monitoring. And there are a lot of the array of things that they carry out. And the monitoring is more about ascertaining the extent of compliance in the parks and the forests. And it also helps in the evidence-based decision-making. And monitoring has always been more as an opportunistic activity than systematic. There are so many factors behind it. And direct, indirect methods. So there are many ways of doing the monitoring. Directly, basically we go and observe, like the tiger, but the species count or survey interview, and probably the real-time monitoring of the aircraft could be direct. And there are indirect ways of monitoring. In my previous work that we did, the GPS collaring of the big cats, snow leopard, and the tigers, and the camera traps, and then satellite remote sensing and automatic trail counter, these techniques. And also lately, there is a lot of hubbub of the digital trace or the footprint, because we use the smartphone, the apps. Some are navigational, so some are just the apps. And then with that, we also use that to see the mobility of the people in and around the area, so which is the aggregated anonymized mobile device data. And in the monitoring, the crux is about the calibration or standardization of the instrument. And the GIS in monitoring is quite big, and it started, I think, around in 1960s. That in the lake of here, they looked into the behavior of the recreational boaters, spatial, like how they behave in the lake, and they came up with some kind of distance decay function. The usability decreased with the distance. It was something like, I think, the power law. It was in 1960s. I think that was the first when spatial techniques were used in the monitoring, and then the GPS tracking to map the uses. And then we have the ADSB, automatic dependent surveillance broadcast for aircraft compliance monitoring. And then we also conducted the privacy enhanced mobile device from third-party services. And there are the tools like ArcGIS Pro supported by ArcPy, and the QGIS supported by Python, and the geospatial packages like SP in R and GeoPandas for the monitoring of the data and the visualization. So back in those days, when they started GIS for monitoring the ecosystem services, the recreational services, and I think it was in 1980s that they conducted in Idrisi software, where in the Berlin Lake, probably Delaware or Ohio, that here the white spots are the most enjoyed, and they brought those information and they digitized in the lab. And the first attempt, the early, effort to carry out the GIS application in monitoring the spatial behavior of the users back in 1980s. So there are a lot of challenges in this area because the parks and the forests, they incorporate vast area of public land and the water bodies, and they also have to expand services, outreach to wider communities, minorities, and also there is an issue of coverage and cost of each monitoring system. And also the system is continually evolving, and we have satellite communication tools, and there is always increasing demand for recreation, as we saw that in the 4 Southern California national forests, estimated 7 million, I think it's more than 7 million visitors. They go there annually. And in the Great Smoky Mountain National Park in 2020, more than 1,400 air tours, which means, and also it was during the COVID time. And also there is an issue of the timely analysis of big data. And the first study is about the active space from low-level overflights in Great Smoky Mountain National Park. So here we talk about the soundscape, the total sound, man-made or natural in an area. However, natural soundscape is a protected resource. So animals, they tend to exhibit response to noise of 40 dBA, and then the impacts are clearly visible below the noise level of 50 decibel. A is weighted. And then the active space is the organisms, they possess the audibility skill, like the mechanism that they create an active space around their area, like the dolphins or the bats or the whales. So that's what we call the active space, where the audibility is there. And in the parks, we have seen that the aircraft and the road vehicles are the most common sources of anthropogenic noise. And as always, the construction of the noise propagation model is not an easy task. So here we were trying to do trying to create an active space from the aircraft noise by pairing the acoustic noise or the noise data and then the aircraft data. And we were looking into three questions that led to the three questions. Are there similarities or differences in the types of the aircraft while we were doing the spatiotemporal joining? And can spectrogram be used to distinguish or differentiate the types of the aircraft? And are there differences in the active space based on the aircraft types? So the crux is we have the ADSP data, which gives us the aircraft tracking flight data. And we have the sound data where we have the mic and the noise propagation depends on the azimuth and the slant angles. So we have the aircraft data on the left-hand side from ADSB data logger, and we have the noise data on the right-hand side, and we are trying to pair these two sets of data. So methods is quite simple. So first we gathered the aircraft data, ADSB data, and then we have the noise data from sound level meter, and they were collected in the months of 2022 and 23. And the NPS has the open source software known as NPS Active Space Toolkit. So it has got two modules. The first one is the ground truthing, where we pair the aircraft data and the noise data. And it makes use of the noise model simulation known as NIMSIM, which uses the Nord 2000 algorithm that's been widely used in Switzerland. I think the scientists from Switzerland. And it helps generate the planar polygon active space and makes use of the digital elevation map during the construction of the noise. And then here, as we know, the noise propagation model makes use of the geometric divergence, the atmospheric absorption, and the ground diffraction reflections. So like these are some of the important physical aspects that they have to incorporate when they carry out the modeling. So the study site, it was in the Great Smoky Mountain National Park. And here we can see there were 3 yellow dots, the ADSB data loggers, and there are 3 pink dots for the sound level meters. So that's how we collected the aircraft data, and that's how we gathered the aircraft noise data. So for our experiment, we chose the Cades Cove site, and the boundary 80 kilometer by 80 kilometer for our work. So the first one is the ground truthing module of the open source software. So here, the top one, the box is that's our site where we are going to carry out our analysis. And here the cross point is the listener's point, or where we install the microphone, and the lower part is the spectrogram, where we can see the intensity or the loudness of the noise. So here in the lower part, we have the window, and when we move the window, we can, and that change is also seen in the upper part, and that's how we select the audibility of that aircraft. And here, the track points are shown by the blue dots. So, and this one was carried out for the jet aircraft. And then we have that spatio-temporal joint of the jet aircraft. Here it's quite small. The listener point is here shown by the black cross mark, and here the blue ones are the audibility section of the aircraft track points, and then the red ones are inaudibility. So we have numerous 625 flight lines of the jet aircraft, and they tend to be quite straight, and it is above our Gatescove site, which also has Gatescove Historic District. And similarly, the propeller aircraft. So we found one typical propeller aircraft that has the curvy track. So, and then the cross mark is our listener point or the microphone. And then here, it's a bit smaller, the intensity of the sound, where we can also see the Doppler effect. And from that experiment, we were only able to extract 65 flight lines for the propeller aircraft, and from 36 different propeller types, aircraft types, and the track could be seen over here. So, and this is the audibility part, and the red ones are the inaudible part, and we can see also the other arc type of route. And then we looked into the spectrogram morphology and the amplified version, where we have the aircraft and the bird calls can be easily distinguished. But when I looked into the jet and the propeller vis-a-vis, it was a bit harder for me to distinguish or clearly say this is from the jet or this is from the propeller. Probably needs an expert listening skills. So the key results, we were able to carry out the ground truthing or the spatio-temporal joining of the noise data and the aircraft data, and we were able to do that for the jet and the propeller. And this study would definitely will help maybe in future to carry out the active space separately for two different types of aircraft hovering in an area of interest. And when it came down to spectrogram morphology or the spectral pattern, it's kind of easier to separate like the bird calls vis-a-vis the roads vehicle. But for the jet and the propeller, it wasn't that easy to separate, distinguish the sound. And probably if we are very interested in the sound recognition, then nowadays deep learning can provide a way out. And there are a lot of experiments that they have done using the modules in the deep learning. And also during the study, I found that we probably need to increase the sample size of the rotorcraft and propeller, because during that sampling process, I only encountered one rotorcraft. And then the two is about examining the aircraft tracking technologies in Denali in Alaska. So the study area is in the Arctic Circle, Alaska, and where we can see that the darker part inside is the designated wilderness, and the park and the two preserves. And then as I mentioned earlier, the first one is the ADS-B system that we analyzed. The aircraft fitted with ADS-B out equipment, and that connects with GNSS, satellite system, the high orbit geostationary, and that gives us its latitude, longitude, and also the altitude or the Z value, and that would be communicated to the ground controllers. And also we can capture the data using the simple data loggers on the ground with no terrain shielding, and then we bring that data to our computer, and then we carry out the analysis. So this is the schema of a ADSB system. But at the same time, there are aircraft, they still use the onboard navigation system known as the onboard GPS, where the small lightweight equipment is installed in the aircraft, and they communicate with the low Earth orbit small satellites, and then they gather the data and they send the details to their subscribers on their phone or on their computer. There are so many commercial satellites now operating. And the flight surveillance is about flight data monitoring, the systematic capturing of the flight data. And in National Park, there is the commercial air tour reporting data format where they have to submit their air tours data. And now there is the ubiquitous use of the ADSB system. But at the same time, we have seen that the aircraft are also using the onboard GPS system supported by low Earth orbit satellite navigation system like Garmin, SpiderTrax, Web Sentinel. And the uses of any device relies on the cost and the broadcasting signals, high frequency, more money, and spatial coverage and the accessibility to the ground equipment sites. And also there are the legal instruments. And flight compliance monitoring has always been a challenge in aviation sector and also for the parks. And Alaska, only 10% of the state is accessible by roads, and there is heavy reliance on air transport and also heavy aircraft accidents. And also visitors, they go to Denali or to those areas to enjoy the soundscape or the natural sounds and the opportunities for solitude. And also there is an issue of analyzing the humongous data that we have in hand, the timely analysis of the data. And we were looking into which technology is effective for tracking aircraft in parks in the protected areas. So what are the differences in the spatial extent? What are the difference in the spatial coverage? And are there differences in the altitude captured by onboard and altitude captured or recorded by a ADSB system? So the simple flow chart, we had the ADSB data, and then we had onboard GPS. The ADSB, the high frequency data, we have more than 9 million waypoints, and then almost 900,000 waypoints for the onboard GPS. And we had these two feature classes, and then we applied the ArcPy module, and because we need to compare A with A, B with B, or the same flight with the same flight. So that that was done with that ArcPy module. And then once we filtered the files, we have the ADSB file, and then we have our onboard GPS file, and then we applied Python and R to do some statistical analysis. So this was not the aim of the research, but on the way when we developed the code, we were able to come up with the two tools. One is parsing the feature class, and the next one is the screening the waypoints. So as I mentioned earlier, the aircraft NA12, we were able to extract the two data from ADSB both and from onboard GPS. So here we can see the blue ones are for the ADSB and the browns for the onboard GPS. So here we can see the frequency of ADSB is quite high. We can see the dense points. And from this data, we then took out only the flights that were captured, that matching flights captured by onboard and ADSB. So there were, I would say, 4 flights that were carried out by NA-12 aircraft, and we have the matching flights. The blue dots were captured by ADSB data logger, whereas the browns from onboard GPS. So 3D visualization. As we can see that as the aircraft was going to the head of the glacier, the blue signals were lost. Only we can see the brown dots. So, and the grid analysis to see the spatial coverage. So this one, for the aircraft A12, with the grid size of 925 meters, in order to see how the waypoints are distributed, and gives us the idea of the spatial coverage of the waypoints from ADSB vis-a-vis onboard GPS. And also we use the update rate or the update intervals or the ping rate. As I said before, that the density quite higher for ADSB. So the ping rate is quite high. The ping rate for onboard GPS lower, but it was consistent because after some time we lost the ADSB signals, probably when the aircraft was hovering near to the head of the glacier. And the altitude discrepancies, usually there were few caveats when I carried out this part of the research. Here, I presented 2 cases where there was no significant difference in the altitude measurement by onboard and ADSB. And one is there is a significant difference in the distribution of the altitude. So this first one is like we don't see any significant difference. The PP value is a bit higher. Whereas in this case, here the mean difference is statistically, that's quite gap. So here the p-value is also highly, that's also highly significant. So this was from the aircraft ND2 flight 16. So that ND2 in the dotted oval, inside there we can see, starkly see that the ADSB, the blue dots are higher, whereas the brown dots onboard GPS at the lower altitude, recorded by those two systems, in fact. So the key takeaway is the ADSB signals, they cover 70 to 81% of the spatial extent of the onboard GPS waypoints in Denali. And also the spatial coverage, ADSB covered almost 84% an average of the onboard GPS in Denali. And out of 223 flights, 171, majority of them showed the statistically significant difference in the mean altitude of the waypoints. And when I was, bogged down with this analysis, then the cubic spline function algorithm with the boundary condition could be developed to fill the gaps of the waypoints, because we can see the gaps even in the low orbiting satellites. There were gaps because systems are not perfect. And also, while doing the comparison of the Z value, it's also very important to pair the waypoints. So in the future, pairing of the waypoints, and then that gives the absolute measurement of the discrepancies in the altitude measurement by the two systems. And the last one is the understanding the visitor's choice for recreation of alternatives or at the attributes of the sites during the wildfire and the drought conditions. So the study area, the Southern California and the four national forests, Angeles, Cleveland, Los Padres, and San Bernardino. So, in fact, fire is a disturbance in the forest and grassland ecosystem because fire is needed. But there are issues with the fire, and there are prescribed fire, and then there are wildfires. So the number of large fire and areas increased in the Western US from 1984 to 2011, and the trend is quite significant in the southern ecoregion, and the annual burn area increased by 5-fold in the Southern California from 1970 to 2018. And in 2020 alone, the wildfire burned more than 4% of the state's roughly 100 million acres of land. And I think lately, I think it was in Florida or in California that I saw in the news yesterday, the wildfire. And we have the environmental stressors, the climate change induced drought and dry spells. And the problem is the peak outdoor recreation time in those areas and the wildfire season coincide and accelerating the situation. And also the issue of drought is not new for the Southern California. And usually drought is said to be the low level of rainfall in an area. So, and the scientists have they have defined 4 types of the drought: meteorological, socioeconomic, and 2 others. And in the Southern California, there were severe droughts in late 1920s to early 1930s, known as the Dust Bowl drought. And then in 1976, and then in 1980s, and then the latest one is 2012 to 14. And lately, the drought has been associated not only with precipitation, but also with the extreme high temperature. So I think 2014 temperature annual mean was one of the highest of that area. And drought has always been associated with the agriculture. When we say drought, hey, the economic loss or the loss in the GDP from the agriculture point of view, and there is hardly any estimation for recreation loss. And then the discrete choice model, the model where the decision processes are influenced by our behavior, like which college to attend, which house to buy, or which travel mode to use to go to the college. So for the house, we probably need green painted house or the white painted house, or the house near to the mountain, or house near to the lake, or the house far from the city center or near to the city center. So these are the attributes that dictate our choice behavior. So attributes of the alternatives. Suppose in the travel mode, if we have car and bus, then we look into especially the cost and time. And there are other factors also, but at a bird's eye view. So these 2 attributes or the level of the attributes dictate which travel mode am I going to use to go to the college. So it's the random utility model. We have representative utility plus the random stochastic part. The U is the random utility model, and which relies on the characteristics of the person as well as the attributes of that site or that alternative. And always, why I choose alternative I? Because the utility of I should be higher than the utility of J, or the alternative I's should be higher than the J utility. And there are limited studies on the recreational services provided by chaparral landscapes predominant in the Southern California. and very few on the regression, visitation dynamics, and displacement due to wildfire and drought in those areas. And the chaparral biomes are the shrubs like short plants, and they also have the Mediterranean type of the climate, a bit warmer, and a perfect recipe for the wildfire. So how do the recreational uh, they respond to the wildfire and the drought in the 4 national forests of the Southern California? And this led to the 3 questions: which site attributes are important for their choices in case of the wildfire, and which site attributes are important for them when there is a drought, and are there differences in terms of their socioeconomic characteristics, the preference, heterogeneities. So the same study area, we can see that the red dots are the survey sites for the wildfire, the 4 red dots, and then the 4 blue dots for the drought survey sites. And the methods, the same, where the team identified the site attributes and the labels, and then we used the experimental design with fractional factorial that gave 8 blocks, and each block containing 9 choice sets. And these blocks are randomly assigned to respondents. And then the survey was carried out at 8 sites in the peak time of June, July, August last year. And then also we captured the individual characteristics like ethnicity, expertise in outdoor recreation, income, gender, age, and visiting with the kids or the children. And then we had 2 models, the effect and the interaction. So methodology, as I said, we have the attributes, activity, travel time, facility, trails, views, feature. And since these are the categorical variables, the brown ones, the same activity versus the other, and then also the travel time, 1 hour, 1 to 2 hours, more than 2 hours. So these are the brown ones are the base category. When we created the dummy variable, we do the comparison against this base category. For the trail, we have easy, moderate, and difficult views, city, wildland, and urban wildlands. And for the feature, we have mountain, wildlife, wildflower, and water. So an example of one choice set. So in the middle column, we have the site attributes. And for site 1, the label of that attribute. Site 2 has the other label of that attribute. So the respondent looks into all these labels and then choose whether to go to site 1, site 2, or stay home. So these are unlabeled alternatives. So here, as we can see for the last row, the unique feature, whether you want water feature or whether you want mountain peak. So based on these labels, they will opt for site 1 or site 2, or they just stay back home. So the descriptive, we have complete surveys, 248 for the wildfire and 163 for the drought, and the unique zip codes, 110 for the wildfire, 129 for the drought, and the median distance traveled miles, 9.9 for the wildfire and 35.8 for the drought. And the descriptive, where I only picked the majority of the high level choices because it's a long list. So here the primary activity, it's quite normal, hiking and walking in both the surveys, and frequency of visit, basically a few times a year in both the cases. But in the drought, they also have quite a big number of first timers, and the time spent, majority of them 1 to 2 hours, and also 2 to 3 hours. And people prefer to travel in a group of 2 to 5 in both the cases. And the recreation expertise, intermediate level, higher. And in the wildfire, the committed was also higher. And the ranking of the attribute, they reckon that the activity is the primary area of concern for them in both the cases, and the income above median of that 10 counties, 54% in the wildfire, we say rich, which is only 30% in the case of the drought survey, and the age group, majority of them 1845 years of age group. And this is the main effect. So here in the label, we only have the dummy variable. I haven't, and then we do the comparison against the reference or the base label. Suppose activity, we have the same activity, and here we have the other activity, different activity. So in order to eradicate the kind of confusion when we look into the messy data of the table, I only brought the statistically significant. In the wildfire case, the views were statistically significant for the respondents, and similarly for the drought, the travel time, and also the difficult trail also came out to be statistically significant in case of the drought, and the p-values 1, 5, and 10% level of significance. And so the other demographic or socioeconomic variables, we have ethnicity, outdoor level of expertise, gender, income, age, and traveling with kids or group of children. So we have the whites as the base category, outdoor expertise, general as the base level, gender female, low income is 1845, and the group only adults vis-a-vis group with kids. So that's how we do the comparison in the dummy variable case in the categorical variables. And here I only picked, we conducted the interaction of all those demographic characteristics or socioeconomic characteristics with the site attributes. And here I picked only the key ones. So here, Hispanic Asians, they prefer moderate and difficult level of trails as compared to the easy trail related to the whites. So, and also the level of expertise, intermediate and the committed, both categories, they preferred moderate or the tough or the difficult level of trails as compared to the general respondents, as compared to the easy trail type. But I highlighted this one because the committed people, they didn't, negative sign here, they didn't like the wild land urban feature relative to the city view, relative to the general level of expertise group. So, and then whereas the group with the kids, they prefer the semi-developed facility as compared to the primitive facility type. And similarly, the interaction effect for the drought, it's kind of interesting because in the drought area, we have the higher number of Hispanics or Latino as well as Asians. Yeah, they have shown dislikes or the likes preferences. And here also a group with the kids, they prefer wildlife and water feature as compared to the mountain. And also here the income category, here the high income category, they didn't like the water feature relative to the mountain as compared to the low income. So it's kind of interesting to see how the preferences varied across these socioeconomic groups. And the key takeaways in the wildfire survey, preference for viewshed. And in the drought survey side, Hispanics or Latino visitors were comparatively higher in number. And Hispanic Latino preferences, earlier it's quite narrow niche. Now it's wider. And also in the drought survey sites, the growing Asian visitors. And also, it's kind of interesting to see the heterogeneity in the income groups for the feature attributes, and also the preference difference for the age groups in the drought survey. And in the future, when we are there to design or formulate an action plan, then probably we need to focus on a specific forest or the site and for a certain socio-demographic group. So, and my thanks, Brian, Sean, Adam, David, Sherlyn, Damon, Tyra, Elisa, Jose, Elizabeth, Sean, Stacy, David, Tony, Jason, and Sarah, and all my lab mates who helped me to come to this point. And here I'm able to present, and soon we're going to publish our papers also. So thank you very much.